Yeah, guys. It's recording now. Okay, it's visible, I guess, PPT for everyone.
Yeah, Ashit.
Fine. This is the architecture of which and all the routers, where it is placed, particularly. Okay, and various access routers and which level of and at which level which routers has been installed. This is the overview of that one. Yeah,
So basically, at the access level, we use 920, 901, and ASR 9, NCS 520, which is also XC.
yeah,
So, and in aggregation, or basically you can say a PE routers or something like that, we use ASR 903 or 907, because 903 and 907s are powerful chassis, and 920 is like a sandwich box, which is used at the access end.
yeah. I will take it over.
Yeah.
Yeah, this is the access level where and all we will use 920 series router and 901 series. And these are the like ASR 900 series routers where we will use 903, 902, and 907. Now this one. This is the aggregate level routers. And if we come for, yeah, this is the aggregate level routers. And this is 900 series. They we will use core routers and also some of the additional routers we will use here. And rest all is like a 9K series. Everything will be used to. And we are working on this. Our XC team will be working on this ASR 900 series with including access and aggregate. This is one. And this is the backhaul connectivity where we'll be having which and all the routers where it is connected. And here we'll be having, normally we will see in physical like wherever you go around in some areas and all around top of the any home or any like empty site and all, we'll be having towers. In that type of towers, our 900 series like 920 series will be installed. In that our job, I mean that our router job is just to segregate all these parts and all, what are the incoming packets, whatever it may be, messages, video calls, whatever it is. It will just segregate and it will pass to the signal sectors. So it will be passed to the parent device. If this device is knowing the address, it will directly send to our neighbor device. If it is not knowing the address, it will be sent to my aggregate router. Here we will be installing 903 router. This is the main router we will be working. Our team, normally we are working on this 90, 902 and 907 type of routers, aggregate level routers. And these are normally 9K series routers they will use. And if you come for hardware part, where as I told, aggregate part, this is the modular ASR 900 series routers.
Okay, whenever you move to next slide, just ask if anybody has any doubts. And
Yeah.
please may other guys as well, all the EIGs, please make the session interactive. If you have any doubts, ask.
Yeah,
Actually, I have a doubt. What is a
yeah.
sandwich router?
Sandwich is
router
like
means,
yeah, okay.
yeah. Sandwich router means you cannot, there will be no line cards will be there. If any power module fails, you need to replace with complete chassis. Complete, like I mean,
See,
complete.
it's not like line card is not there. It will be
Ah.
fixed onto the chassis. So all the components are fixed onto the chassis. Even if one single interface failure happens, we have to replace the whole chassis.
Correct. I will show just one image so you'll get an idea like what is 920, how will it will look.
It's
Yeah,
like integrated to your motherboard or something, like you can say.
yeah.
So this is completely fixed here.
Fixed. If any
Yeah,
port going
hello.
fault, yeah, please tell me.
Hello. Actually, customer is using the access level router, okay, but customer want to use the AC power supply instead of DC power supply. Can I replace a new devices with DC power supply with the old device with AC power supply? Is it possible to? Is it possible
In case
the
of
access?
in case of ASR 920, you're asking.
Yeah.
See, if it depends upon, there are different models available in ASR 920 where the power module is removable, is an FRU, or sometimes it is fixed. If it is fixed, then there is no other option rather than going for a new model where there is an AC power supply available. If it is not fixed, then also we have to check the, there is something called as power compatibility, power module compatibility, right? So whether we can use the AC power with that particular model or not, we have to check that.
Yeah, in this image, you can just check. Okay, this is 24 module port. Okay, in this you can AC and DC both will be available. If they're using 24 module as Digvijay told. Okay, there will be some options for AC and DC to change. If they're running in AC, it can be.
I guess can use AC or DC at use. If you are using the AC, then only AC only you are using.
Yes, it cannot be a combination of both.
Correct.
Either it can be DC or it can be an AC. It's not like even in ASR 903, some cases have been there where the customer is using AC and DC both, but it works, but it is not recommended. So it's like a completely, unexplored domain where the customer experimented it work. Sometimes it doesn't work as well. So that is something which we have to stick to the ground rules. Whatever Cisco recommendations are there, we have to follow that irrespective of the fact that the device is working stable normally or not. If it has to be DC, it will be DC, and if it has to be AC, it will be AC. No mix and match there.
Okay, this is the sandwich box as someone asked here. If any port goes faulty in this port, if the customer required replacement, we need to replace the whole router. That is a sandwich box, what we call. It is completely packed up. We cannot able to remove any line cards like as we do in 903 or 900 or 907 or 902 routers. Okay. Then if you come for our aggregate routers, as I told, here is our 903 routers, where we will use most commonly 903 routers we'll use. In rare cases, we will use 907, and commonly we will use 902 also at the aggregate levels. And these are different types of RSPs we are having: RSP1, RSP2, and RSP3. Most commonly, we will be using RSP3 and RSP2 also. This is like high generations RSP cards, which will be having high performance and will be having TCAM memory. TCAM memory means all we can know that it is capable of going packets completely in like L3 for L3 level. And it will be like high level, flexible for everything. Like it can do access list.
Can you give an example how TCAM is used?
Yeah, normally like if we'll be having two types of memories. One is CAM, one is TCAM. CAM means it is like a we'll use in layer 2 informations. It will be containing layer 2 informations, and TCAM is a higher level information about layer 3 informations. Okay, if we go for like CAM is it is the content addressable memory. TCAM is ternary content addressable memory. As I told, it will be having that routing table. Everything will be stored here in this memory.
Okay. So it is like, okay, exactly what is a routing table, but basically for each TCAM entry, there will be a prefix and the next hop stored. If you see one TCAM entry, there will be a prefix and the corresponding next hop will be there. That is what you see in the TCAM.
Okay.
When you check the TCAM utilization, there will be a limit of, let's say, 65,000 TCAM memory hai. So for each entry, there will be one prefix and its next hop, something like that will be there. So what happens if TCAM gets exhausted? Will there be a traffic impact?
Yes,
anybody?
of course.
Yeah, correct. So will there be a traffic impact for the entries which are already there in the TCAM?
No, not for them. I think it's only for those. I mean, for prefixes, other prefixes won't be resolved if TCAM exhaustion happens.
Exactly. So when TCAM exhaustion happens, the entries which are already there in the TCAM, that traffic will flow normally. anything which is coming new, the entry is not going to get registered. So since the entry is not going to get registered, the traffic is not going to pass for that particular prefix. So there will be an outage, but not for those which are already registered. Right. So there are two things. Now, one is a default TCAM utilization, bandwidth or allocation, you can say, which is there on all the ASR devices. So we can do an extension of it. Let's say if there is we are hitting a hardware limitation where we are actually exhausting the TCAM utilization. So there are certain commands using which we can extend the TCAM memory. So additional memory will be added to that TCAM quota. So as to resolve customer requirements. But at the end, the customer is hitting a hardware limitation and he has to upgrade the device. So that is there. Okay.
Exactly.
And second thing is we will majorly use RSP2 and RSP3. RSP1 was there is in ASR 901. So ASR 901 is something which is not being used right now. In very few cases you will see for ASR 901.
Yeah, some organizations they converted ASR 90 into switches.
Yeah.
They are using it as switches, but ASR 901. Okay.
Okay.
It will be having like why we require TCAM means it will be having more capacity, as Dikvijay told, because MAC addresses required exact match to reach the destination, but IP addresses doesn't require exact match. If that network is there, it will be like in that routing table it is there, it will be automatically going to destinations part. So TCAM is having more memory comparatively CAM memory. This is the one part.
Okay, this question is for EIGs.
Yeah.
So do you know route selection criteria and all that stuff? How the route selection criteria happens in a routing table? Like I have 3 entries for a same route with different subnets. Which one would you select? What is the route selection criteria? Anybody? Kindly interact, please. If you know or if you don't know, just let us know.
I'll take a guess. I feel that
Yeah,
the
sure.
exact match, we will go for the subnet which has the most number of matches, like the closest one. That's
Yeah.
what we
So
can.
the technical term for it is longest prefix match.
Yes.
Yeah. So first will always be preferred as longest prefix match. So the next stop for that longest prefix will be taken rather than other two. So anyhow, that will I'll take a basic session as well in the next week. So okay, continue.
Yeah. Okay, this is our hardware modules of RSP3Cs, and this is the capacity of our complete RSPs, aggregate routers. This is RSP 903. We will be having 4 line cards and 1 RSP, maximum of 400G. And this is our RSP next 903. We will be having 6 line cards with 2 RSPs, RSP0 and RSP1 of maximum 560 GBs. And this is our ISR 907. We'll be having 16 line cards with 2 RSPs, and we'll be having 3 power modules. And for these 2 cases, we'll be having 2 power modules. If any power module plays, normally like how we'll raise RNA cases, that we need to cross check and we need to go ahead. And we'll be having a fan tray, which you can see here. This part actually, okay, this is the fan tray that will avoid the dust, and we will control the temperature of the router. We'll be having maximum and minimum temperatures for particular routers. Maximum will be around 56, minimum will be around -40, something like that. If that exceeds, the router will go automatically reload. So when unexpected reload, we get a case like router got unexpectedly reload, what is the issue when the customers ask? We need to check this type of one criteria also. With the show environment, we can just check what was the temperature recorded before with our normal logs and all. This may be one reason that maybe router will get reloaded automatically, because in some of the areas we'll be having high temperature, we'll be having low temperatures. At that time, we need to cross check all the things. And this is our maximum. This is what are the slots we can use, and what are the RSPs we'll support here. IXC and XR devices. And this is summary of our RSPs. RSP 902. We can use 4 line cards with 1 RSP and 2 power modules as I told. And this is one like fan tray with removable fan filter will be there. Normally, like 3 months or 6 months once, they will filter this one so that any dust particles, here will be the filter. It can be removable. This side line will be there. There is a filter of that one. It can be replaceable with new filter card, with new filters. And this is normal. This is similar to that one. Like you'll be having more line cards with additional 1 RSP. And this is also same as this one, our 902. And this is also 907 with 16 line cards. These are the like hardware architectures of our ASR devices, aggregate routers. If we come for okay, any doubt in these sessions in hardware architectures? These all sessions, guys?
Actually, I'm wondering if we don't need to remember all of the specifications, like
No. You don't need to remember all of these specifications. One of the reasons is all the data sheets are available online.
Yeah.
Whenever you have to refer, you can refer to the data sheets. You can search it on Google. It will be readily available. Second thing is, it is very, when once you start working on all these devices, you will automatically get to, with experience, you'll learn what all devices or what all RSPs are used and with what all products.
okay.
So there is no need to memorize it. It's just for you to understand what all parts exist and what all devices uses what all RSPs.
Correct. If there is L0 means this is from last we need to calculate 0, 1, 2, 3, 4, 5 like that. If that if the customer tell that slot 0 we are having line card slot 0 we are having issue means that is the base one. And RSP 0 means that is the from downwards it is the first one like that.
And where are the
Sometimes
subslots? Like
yeah, subslots are these are the line cards or subslots we are having. Chassis you will take it as 0. For example, you will get subslot 0/0/4 particular port number. We are not getting traffic in particular port number. MAC address is not learning in particular port number, and customer will mention that 0/1/4. So 0 is your router, and in that first card, in that fourth port, like that we need to calculate. Got it?
Yep.
And these are our cards which I told. These are RSP cards. RSP3C 200S, 400S, and 400W. We can use for all 400S and 200S will be using in 903 and 400W with 907. Different types of RSP cards we'll use in different models of our aggregate routers. And this and all like that.
How are these S and Ws are different? What is the difference between that?
Between which one?
Like RSP3C 200S and 400W.
This is the capacity of the routers. How much capacity they can handle. Traffic capacity.
200 and 400, this gives you the bandwidth, 400 Gbps of traffic it can handle. And when it comes to S and W, there is some internal architecture difference. That's all.
Okay.
Yeah. And these are the different types of line cards. This is one model in that line card. This is 100G capacity in single slot. Like we will be using different type of SAP for this one. SAP means normally we will tell us it is a transceiver model. It is a small factor model, so that when we got any interface down cases or customer will tell that port is not getting up At that time, we need to check the SAP also, whether SAP is working properly or transceiver model is working properly or not. At that time, you need to cross check, because uh, at that time we will be having some issues with SAP. It will be just receiving the traffic. It will be not running the traffic. It will be not transmitting the traffic on that particular SAP. At that time, we need to cross check with giving loop or whatever it is for particular SAPs. And this is one more IM slot. Like we'll be having 40G interface model to a maximum around 80 GB we can use here. In each port, we'll be having 40 GB of traffic in this port. We'll be having different types of IM models. This is like we'll be having all our 10G ports with maximum 8 ports. In these 8 ports, we can use in single port, we can use 10G traffic. These are different types of models. I will show in further what are the types of models we will be having. IM models, interface models, will be line cards and all. Yeah, these are the different types of line cards we'll be using in RSP 1, 2, 3. In future slides, it is there. I will show you that cases. If you come for architecture, hardware, this one is the one we are having. Yeah, this is the in this we will see how the traffic flow will be there inside
I have a doubt.
RSP. Yeah.
Like in SFP, when our end is not receiving or transmitting, then what should we do in order to troubleshoot that?
Yeah, first, if you should do the physical troubleshooting, they will be having some patch codes in the which will be connected to the SAPs. In that SAPs, you need to check by looping the patch codes. First, I will show how the SAP looks for you guys. See, these are the trans receivers SAPs. This all like will be having different types of SAPs. In this, we can see two gaps. One will be transmitting, one will be receiving the traffics. Okay, there will be different types of makes. Cisco is also one. We are making SAPs, and different vendors will be there for that one. In that, you should check whether the SAP is correct or not. First thing, if any interface down cases, if you receive that one. In that one port, as I told, it will be transmitting, receiving. First, give the loop to the SAPs and then check whether the port is coming up. If the port is getting up, then there is no issue with SAP or hardware. There will be issue with some traffic flow, or there will be some traffic cut or fiber cut, like that will be there.
Okay.
Yeah. And also, okay, yeah, please.
Yeah, I was just going to tell you that there are multiple types of SFPs, like RJ45 copper cable, optical fiber. The one which Harshit is discussing is optical fiber, where we will have a different transmission and receiving line. So yeah, that is there. So one thing is like whenever we do a check, like we are not receiving traffic on the interface. So there are certain commands where we can check if the power received on the SFP is right or not. If it is low, so we have to check whether it is low for transmission or reception, so TX or RX. So if it is low for RX, then it is an issue on the remote end, maybe fiber cut, or the remote end SFP, there might be an issue. Or if it is on TX, then it might be an issue with the SFP. Second thing is like you have to identify like if SFP is working fine or the port is working fine. So there are two very simple steps. You check this SFP on another working interface, or you can simply do an internal loopback testing on the interface to check whether all the ASIC for that particular port is working correctly or not.
Yeah, and also one thing I noticed is there are documentations available for compatibility matrix between different SFPs, the versions we are running, and different ASR 920 boxes also. So,
Yes.
So if you just go through that documentation as well, just type it on Google. It's readily available, compatibility matrix, to check if one particular SFP is compatible with the version you are running or not. So
Okay, no need to do that. I am pasting a link in the chat, which will help you. It's a Cisco link. So it will give you you just have to copy paste the SFP module for PID, that is product ID, it will give you for all the devices, all the iOS versions, support, and whether it is supported or not. That is there in the chart.
Yeah, these are types of SAPs we will use. There will be minimum and maximum threshold for that one, as Likvijay told. We need to cross check whether we are receiving maximum threshold or minimum. Then we need to update. That's it. Nothing else we can do. If anything hardware issues, we can just resolve. Yeah, this is the architecture of how it will flow in 903. Like we'll be having different types. Control panel and data planner will be there for each and everything. Control panel is that responsible for exchanging the routing information using my routing protocols and build a routing table and arc table. And data plan is responsible for actual forwarding of the IP packets. That how the IP packets will be forwarded from one device to another through any backhaul media, whatever. Okay. Then in our perspective, generally what we'll be having, we'll be having management plane and data plane and control plane. Management plan is like all packets or traffic will be added by the CPU, like OSPF or ISS. These are handled by management plane. Any ping traffic that will be handled by management plane. That you can see here CPU. This will be handled all my management planes. And control plane like CLI sessions or telnet sessions. These are controlled by control panel. And data planes are
Okay. Stop, please stop. I've again told you last time also you made the same statement. Don't confuse it with the data management plane and control plane, because control plane is something which we use for protocols. Right? And you are mentioning it that it is being used by the management. So you have to differentiate between the working of both the planes. Management plane, just consider it as in a plane where the internal management of all the parts of the router is taking place. I2C and all internal bus communication happens in management plane. Right? In control plane, all the protocol convergence, protocol establishment packets are being processed in control plane. So control plane is bringing up the protocol. Data plane is passing the traffic based on the information done on the control plane. So this is the simple explanation. Don't confuse it with the, because once you say it, that ISIS or OSPF packets flow through the management plane, or ping packet goes to RSP or management plane, that is not the right terminology to use. It will confuse everyone, because even if the customer also knows the same concept, that control plane is something which deals with the protocol processing, and data plane is something which deals with the traffic processing.
Yeah, most of the IP packets are forwarded by the data planes, but there will be some special IP packets that cannot be forwarded by data plane. It is done by control panel. For example,
so ping packet. Any ping packet, what happens is, I'll give you a small, I'll take a detour from this topic and explain you one small scenario. Let's say that there are 3 routers. We are pinging from router A to router C. Right. So we'll have in the IP packet, we'll have source IP and destination IP. Source IP is router A's IP and destination is router C's IP. In the layer 2 header, we'll have source MAC and destination MAC. So the source MAC will be routers A MAC, taking destination MAC will be routers B MAC, because it's the next hop. Right. So just a second, I forgot the context. So what we were discussing before that? Yeah, control plane and data plane, right? Control plane and data plane. So when it reaches the second router, the router will see that it is destined for router B, right, from layer 2. So it will open it, process it. That packet will go to RSP. RSP will generate another packet with source and destination MAC as source MAC as B and destination MAC as C. And at the end, it will reach to C. So in router B, the packet is reaching out to RSP, or you can say for processing. It is not like transit traffic nahi hai ki they just check the route entry. The processing is happening because the new packet is being generated or new header is being added, layer 2 header. So this is something. Isme agar if I go to little bit more detail, there is a bit called as router alert bit. So basically it is used for ICMP because ICMP has an error reporting mechanism. So when we do a trace route or a trace cert, so if it gets failed, so router alert bit is set to 1 so that all the nodes between the paths will know that it has to go to the RSP and then forward it further. So why am I discussing this thing? There are two reasons. Maybe one reason for it is for ASR 900 series, the line cards doesn't process or doesn't have their own CPUs and memories. ASR 9K, they'll have their own CPUs and memories. In that case, the traffic is forwarded through the CPU available on the line card. But here, all the packets are sent to RSP for processing, to route lookup and all. So for ASR 900 series, all the packets will be sent to routing process RSP for processing or route lookup or further for like traversing the traffic. Either it is a to or a through traffic. So that is why here majorly we talk about it's like a forwarding plane and control plane. Mein zyada difference, we won't be able to see much difference. But when we talk about intelligent line cards, and that point of time, it makes a lot of difference. Because for through traffic, it will not go to RSP. It will simply traverse through one line card to another line card. So in our ASR 903 or 920, it has to go to RSP. That is why it doesn't make much difference whether which traffic will go to RSP or which traffic will be forwarded directly.
So this is like a general method how the traffic will be done. And in our product we'll call as like RP, FP, and CC. Normally it will be like forwarding processor and carrier card and router processor. It is nothing but different names which are given in our product, like management, data, and control will be given as routing, forwarding, and carrier card. Like the traffic will be flowed from one person to other. And these are like IMA models, which I told. Different types of IMA models we'll be having. IMA1X you can use in RSP1, 2, and 3 in this one. And these are like IMA 8S means that is all 1G ports will be used in that particular interface model. 1X means only one port will be using in that line card. 8T means it will be using for all management like LAN connectivity and all. Normal optical SAPs cannot be inserted in that particular line card. LAN cables will be done. 8S1Z means we'll be having 8 1G ports and 1 10G port. These are different types of IMA models we'll be having. Like as we discussed in this one. Yeah, this is the hardware architecture of that completely of our aggregate routers. Any doubt in these hardware architectures? Guys?
No
Hello?
doubt.
No. Yeah, but
And this is how the packet flow will be there. And as I told, this is the control panel which will be controlled by CPU. And once ingress will come, it will just check the, as Vijay told, it will just check the source and destination IP addresses, and it will forward to an trace of this one. Last time we discussed about this, I guess. And in different, like different RSPs or different aggregate routers, how the packet flow will be there. So if you go through one PPT, it will be all of a sudden it won't get. Once you go through PPT, you'll get some ideas then further working on these devices, you'll get complete idea about how the packet flow will be there. Normal packet flows, normal how the packet will switch from one post to another post. I will share this PPT with in group so you can understand. Yeah, this is the hardware architecture and how the packet flows will be there. Any doubts, you can ask Digvijay also. He's very senior. He's will be having all like this one. He's handled all type of cases. And you can contact me as per my knowledge. I will explain how much I know. Yeah, that's it from my side. If anything else, you guys can just share regarding this one.
Can you go back to the packet flow slide and explain how the packet flows on
Yeah.
the line card or on the
This
device?
one. This is right.
Yeah.
Yeah, this one, like when the packet enters the RSP card, it will just check the what is the MAC address, source and the destination IP addresses or MAC addresses required, and it will just pass to like a grace of that one.
Okay. So the
And
packet
in that
basically what
routing,
happens is if
It's
you
like
see port extension FPGAs, right? Port extension FPGAs, NPUs, and RSP. So the traffic will first hit the interface. It will go to FPGA, then particular NPU, and then to the RSP. Correct.
yeah, correct.
Yeah. So RSP will decide where to send it.
Right to see.
So let's say from NPU 0 to that ERES interface is on NPU 1. So it will send the packet to NPU 1. Further from port extension FPGA, it will go to that particular interface. So
it
this
means
way you have to explain.
it means it's learning the it's maintaining the routing table or in control plane.
See, control plane, yes. So
Yes.
control plane contains the routing table. When we talk about data plane, the same copy of the routing table is copied in the data plane. That is called as forwarding table.
Forward.
So
It means
whenever we are traversing the data, so always the forwarding table is referred, because routing table will have information of multiple routes to the same prefix. Forwarding table will have the information of the best route to that particular prefix. Correct. Let's say I have 3 routes. From that route selection criteria, I will select the best and put it in the forwarding table.
Okay.
So whatever
that is
traffic,
data plane will be doing like that is data plane will be doing that job, right? That is
yes.
the best. That is selecting the best path and sending the packet to the next
So
route.
see, that is called as convergence. The routing protocol convergence. Well, let's say for OSPF or BGP, when you see a show route, let's say for BGP, particular prefix is there, but we are learning it from 3 different sources, right? So out of those 3, whichever will be the best will be available in the forwarding table.
Okay.
Okay. So all the 3 routes will be available in routing table, but the best one will be in the forwarding table. So if in case that fails or the BGP is down or something, then the other will come into action. Or otherwise, we can also do a load balancing thing.
We have an equal distance. Yeah. Normally, we'll be having 3 tables like routing table, neighbor table, and topology tables. According to that, our L3 protocols.
That control panel is only doing only managing the routing table or anything it's doing like in platform in hardware platform. It's only like managing the routing table and selecting the best route. That is only doing or what? Any other like
data plane is the most of the packets will be forwarded by data plane. Only like as I told, only we will be having special packets that cannot be handled by data plane will be done by control plane. For example,
all the network control information is handled by control plane. May it be a protocol, may it be any other thing. All the network control information is handled by control plane. That is processed and added into the routing table or the respective tables, and then the forwarding table is further updated.
Okay.
Right. All the new guys, I don't see any question coming from your end?
We are kind of lost in the abbreviations here. Sorry.
Sorry?
We are kind of lost in the abbreviations. The abbreviations you have used is kind of, we are unfamiliar with it. We are not familiar with it.
What are the abbreviations which you are not familiar with?
Whatever we are seeing on the screen also, like NPU, FPGA, whatever you are.
FPGA is a field programmable ASIC, right? It is just a hardware components which are network processing unit, field programmable ASIC. These are hardware components which are available on the router. So it is just to show that you don't have to remember any of these things. It is just for your understanding how the packet flows within the router. So from IM interface module, it will go to FPGA. From FPGA to particular respective NPUs and to the RSP. So RSP will decide where to send the traffic further. So we'll have multiple line cards. So we'll have multiple NPUs connecting to those IM modules. So the RSP will decide that the incoming traffic, the next stop will be this, and that next stop is available in that particular IM interface module or the line card. So it will send it to that respective NPU, that is network processing unit.
Yeah,
So
in this-
majorly all the work is done by RSP.
In this you
So-
can see where and all it is connected, like FPGA, TCAM, right? And this
TCAM, ARET.
Yeah.
This is a very detailed description of how components are connected in the hardware. If you want to research, you can do. It is very good for you to understand the packet flow. But the basic concept, we have to understand how the packet flows in the hardware. So when you run those commands where the terms like NP would be there, or NP mapping is there, so you will know which NP is mapped to which line card or which RSP. Something like these commands are also available, right? So you will understand how the packet is flowing. So interface module hai, post that it will be FPGA, and post that it will be NPU. So the communication between the interface module and RSP is going through NPU. So NPU is the, let's say you can assume it to be a connector between the line cards and the RSP. Right.
Yeah, that was clear, right?
So nobody else other than Harshita has doubts.
Can you explain again about the data flow or packet flow on the data plane? Like, I got
Okay,
about the control thing, but
Okay,
not sure
okay,
about
okay. So now what happens is, let's say it is a through traffic. Through traffic is not destined to me, right? I just have to pass that traffic. So the packet comes onto the interface module. It will obviously be sent to the RSP for route lookup. That route lookup is done on forwarding table. So that for that particular destination prefix, we'll check the forwarding table. Whatever will be the next hop, we will send that traffic to that particular line card or interface. That is as simple as that.
Okay,
This is
yeah.
a very basic idea of how packets flows. If you go dig deep, depending upon each protocol being used, the packet processing change a little bit because there are different ASICs involved for QoS, different ASICs involved for other protocols, right? For route lookup or for packet processing. So the basic idea is for data plane, it goes to forwarding table for route lookup.
Okay.
Okay.
Right.
Yeah. So Danush, Arjun, Himani, Nikhil, nobody has any questions?
I have one question. Can you go to that line card thing? Go to that line card slide.
Okay.
This one.
No, where there was a diagram for line cards.
A detailed diagram.
Hmm.
Yeah, this.
Yeah.
Not this one. In which you were saying na ki we have to count these subslots.
Subslots.
Yeah.
Nomenclature you're talking about.
You want hardware diagram?
Yeah,
This
yeah,
one?
yeah. Yeah.
Yeah.
Yeah. So
Hmm.
I want to ask, like, if there is a problem in slot 0 or any slot, so
Hmm.
are these slots replaceable?
Yeah.
Absolutely. So these
Okay.
devices are called as modular devices. Modular
Mhm.
devices and fixed devices. Or fixed in generic term, we use a sandwich box. We are not
Okay.
supposed to use it in front of customers. It's a, like for internal discussions, we talk like it's a sandwich box. We can replace it if one part is faulty. But usually 902, 903, 907 are all modular box. All the parts are replaceable.
And sorry, this is a silly doubt, but can you tell me exactly in this diagram what is chassis?
Chassis is the box where all the
Box.
parts are installed.
Okay, this whole, okay, this whole, okay.
So the chassis will contain basically, if you I may let you understand, it's like there is motherboard in computer. We install all the parts on the motherboard. Same is the case here. We have mid plane. So in that mid plane, we install all the components. So all the components are interlinked with each other through a mid plane.
Okay.
Okay.
Yeah,
So
got it.
yeah.
Chassis is like empty dabba. We can insert all these cards. These are all separated. Fan module, printer, RSP.
You can
Everything
yeah.
part by part, you can insert.
Okay. Thank you. Yeah, got it.
Okay.
Anything
So
else?
when you do a show inventory, all the field replaceable units, that is all the parts which can be removed, will have a serial number available there. If there is a serial number, it is replaceable. And another just a small information for ASR 920, the RSP is inbuilt and the architecture is similar to RSP2.
Yeah, there will be having only one RSP, right? In RSP 90.
Yeah. So the architecture is similar to RSP2. So all the troubleshooting, whatever we do, is as per RSP2 documentation available for ASR 920.
But one difference is it is a sandwich box. So in this we can replace the parts.
Correct. Anybody, Nikita or Pratiksha, you would like to add some information? Else we'll conclude this session.
No, Digvijay, I think we have, covered most of it, and there is Harshit can share this particular PPT link with everybody.
Yeah, sure.
And
Yeah.
whoever will have their doubts, we can discuss in the group only.
Okay. Harshit, can you stop recording?
Yeah, sure.